Hi everyone. Well, today you join me in my office and what am I up to? Well, I'm having a mess around. Nothing unusual there. But when we come out to site, we're often looking at examples and seeing welded examples here of twin seam welding. Good to see it in practice, but knowing some of the technicalities that go with it, I thought it was worth bringing that home today. So first of all, we're going to have a look at some of the welding parameters that should be a consideration for the guys. Some of the welding parameters here are clearly laid out. Now, Leicester, who manufacture the 20, in most instances we're encountering a 20 T5, and they've done this nice kind of ready reckoner chart for us, working out what membrane we're working with. So in this instance we can see HDPE, if I get my finger out we can stay in focus, or LDPE, low density or high density polyethylene. And as we can see, the different thicknesses that are identified here, so up to 1 or even welds up to 2 millimeters. But then dropping down, we get some parameters here of the actual temperatures that are required for welding in different environments. So LDPE, 1/2 mil thick, they would expect, or they advise that you'll be looking at about 500 degrees, a welding speed of 4.5 meters per minute, with 80% of the airflow of the machine running. But this one doesn't actually tell us for the T5, which is the common one. Unlike the T7 actually gives us some Newton pressure. So let's go back to our sample and have a look at some of the implications that happened there. So bringing back our sample, in this instance, the technician was doing good practice by doing multiples of test seams. So actually run through 3 test seams here, conducted various peel and shear tests. These were done manually, not with the use of pliers or any tensiometers, so just physically getting hold of the membrane. But you can see when we look at them in the first instance, so I'm just going to wander over to this area so I can lay it down flat. So when we look at the actual welds, we can physically see they look tidy. There's a lot of strength. We can actually, start delaminating the material by pulling them away. Yeah. But one issue that came around on this particular job was I asked the technician what was their pressure of the welders, the jaws on the machine. So they were a little bit unsure on telling me that. So what I did, I didn't have, actually I'm going to put my light box on now. Light box, it's just a light I use for camping. Bit of moody lighting for us. Let's just turn the main lights off in the house. And what we're going to do, I'm just going to lift this over and hopefully this comes out. You can see the way the light is actually coming through all them puncture points that are in the kind of formation of the rollers, the dimples in the rollers. When we actually checked the pressure on this, the technician was using a pressure, he couldn't confirm a pressure. So he was quite happy with the first weld. And like we can see, when you peel it back, yeah, it's held it well, but look at all them holes that are letting potential contaminants through. So then we went to the next seam where we started adjusting the pressure. And we actually reduced it down quite significantly here. And in this instance, it was 350 newtons was applied. Again, we can still see light coming through various pinch points. Yeah, so could be the rollers have got slight deviations, but there's no consistent pattern in that formation. So we actually took the pressure down to 200, and we are still getting minor bits through, but 200, you can see how many holes were still present there. So I thought I'd just show you that example. Now, trying to run that test or do that visual inspection on site is going to be a little bit problematic. But possibly using a light on your phone. All phones have got like super powerful lights on, and putting the phone underneath the membrane just to see what's going on there. But we also discovered, just putting the sheets about, it's a great way of picking up little holes in it as well. This was just a little dink in the membrane there, and it shines through lovely. So maybe light testing could be the way forward. So hope that's been helpful. So having some discussions with people within the industry, some manufacturers, some specialists that have dealt with research into different products, but also with the manufacturer, we came across this interesting document that refers to various rollers that are available. And interestingly, you can see from the diagram there that there's different alternatives. So you can get a sharp edge wheel, you can get a blunt wheel, you can also get nylon or silicone wheels with the twin seam or the single seam, so you've got a test channel or not. So it was quite interesting, and we spent some time down at Welling Tool with the guys there with the different machines. Now, all these machines that we went through were compatible with using these different roller methods. And we actually run a few tests. We can see here there's an example of a test that's actually air pressure testing, but we put it under pressure, and we also put it through the light box as well. So and that was a monolithic membrane in that place. So have a look at those rollers again next time your machines are in for servicing with whoever you use. Possibly worth picking up on the various rollers that you can replace or change over depending on the product you're working with. So certainly the silicone rollers or the blunt rollers will work quite well on the foil products and the laminated products. But it seriously shows knowing the thickness of your membranes, and especially when you're using the foil product that we've just seen there. You know, there's a lot of interlayered foil membranes. Data sheets will tell us it's 0.5 mil thick, or in this example, they actually declare that it's 0.4 in between the scrim and 0.6 outside the scrim. So we know that some people take the medium of that, 0.5. So just be mindful of how thin these veneers of membrane are and how much pressure is needed. So it doesn't need a great deal of pressure, but we need to get the right heat and also go at a nice consistent speed. So hopefully that will help.